All right, this section we're going to look at just a few more ideas of graphing linear functions or linear equations. So we're going to graph them using intercepts. We'll graph them using slope-intercept, similar to what we did in the last Scribblecast. Then we'll look at some perpendicular, or not horizontal and vertical lines. And lastly, we'll look at the parallel and perpendicular lines and what their slopes or what their equations look like. So to begin with, if we want to graph linear functions, actually if you want to graph lots of functions, knowing what the x and y intercepts are two fairly easy characteristics to get about the graph. Specifically, if I want to know what my x-intercept is, so where it crosses the x-axis, the value for y anywhere along this x-axis is 0. So what I do is to find the x-intercept, I plug a 0 in for y. So this is to get the x-intercept. I'm going to go 3x minus 2. Instead of a y, I'm plugging in a 0 because an x-intercept is any point along that line where y is equal to 0. Is equal to 6. Now I'll solve the equation. 3x minus 2 times 0 is 0. So 3x is equal to 6. Therefore, x is equal to 2. So I have a point. So when I'm graphing a line, I could get an x-intercept of 2, 0. So 1, 2 right there, 0. That's a point on the line. If I knew the slope, I could from that point go up and over to get to another point. Or I can go and try and find a y-intercept. Because if it's a linear function, all I really need to know are 2 points and then draw a line between the two. So to solve for the y-intercept, I take the same equation, but instead of plugging a 0 in for y, I'm going to plug a 0 in for x. So 3 times 0 minus 2y is equal to 6. 3 times 0 is 0, so I have minus 2y equals 6. And of course, y is equal to minus 3. So my y-intercept is negative 3. So my y-axis is this one. So y-axis is, so it's 1, 2, 3 right there. So this is my y-intercept. Now I have 2 points, so if I want to draw a line between the two, I can. That's fairly close. Let me just snug it over a little bit. So here would be the graph of this function, okay, linear function. So one way to get a graph is to find the two intercepts. Find the x-intercept, find the y-intercept, draw a line between them. Okay, another way, and one similar to what we did on the last question, was to change the equation or the function or the relationship from how it looks here into the slope-intercept form. And we did that a little bit on the last one, but let's just review it again. I need to get y on the left side. It's there already. I need to move the x over. So I'm going to take this x and move it to the other side. So I'll have minus 2y is equal to negative 3x, and this is a positive 6. If you have trouble moving things around like that, maybe contact your instructor just so that you're comfortable with moving things from one side to the other side. I basically subtracted 3x on each side. Now I need to divide everything by negative 2 because all I want here is just a y. So I'll divide, I'll just write the whole thing over again. Minus 3x plus 6. And now what I'll do is I'll take, whoops, uh-oh, that's sort of interesting. You didn't want to see my email, did you? There we go. Okay, so now I'm going to take and divide everything by negative 2. Negative 2, negative 2. Those cancel. I get y is equal to, this will be a positive 3 halves x. 6 divided by negative 2 is negative 3. So now I have the equation in the slope-intercept form. So my slope of this equation is 3 halves. Remember, the top number is the rise and the bottom number is the run. And I also know my y-intercept is negative 3, which I could have got by plugging a 0 in for x. Remember? Just do that mentally. Plug a 0 in for x, solve for y. You'll see you get negative 3 again. Okay, so to graph this, I would find my y-intercept. Here's 1, 2, 3 right there. And now I'm going to rise 3, 1, 2, 3, and run 2, 1, 2 right there. And if I want to get another point, I could rise 3 again and run 2. There'd be my other point about right there. And draw a line in between them. Something like that. Okay, so I can graph a linear function, making sure that it is in this format. So from that I can get my slope and I can get my y-intercept. And then notice over here when I was doing this that I plotted first my y-intercept, and then from there I used my slope. I can't really start with the slope because I don't have a starting point. I need this starting point to get going. Okay, other lines that you might have that we haven't really looked at a whole lot yet are lines that are perfectly vertical or lines that are perfectly horizontal. And these ones, often people get mixed up. So the line x equals -2, or the line x equals 5, or y equals -4, y equals 3. What I want to do is I want to plot those lines on here somewhere. Now, when they say x is equal to -2, what I'm really looking at is I'd like to get it into this format, y equals mx plus b, but notice in this equation there's no y value. Or in these ones down here, there's no x value. So I guess I can assume that that y value or that x value is 0. But it is, I'm needing somehow that I can plot this. What I do in my mind is I say to myself, okay, if this is an equation of a line, it means that x is -2 no matter what. No matter what the y value is, x is -2. So if y is 0, x is -2. If y is 6 or whatever, x is -2. If y is -3, x is -2. And you see the kind of line that is forming there? It's forming a vertical line right there at, x equals -2. Similarly, if x is equal to 5, I can take and I can say if x is 5, so here's 1, 2, 3, 4, 5 right there. That line there is x is equal to 5. Because no matter what the y value is, x is always equal to 5. Similarly with the y ones, if I have y equals -4, there's 1, 2, 3, 4 right there. There's the line y equals -4. And this line y equals 3 would be 1, 2, 3. The real trick with these is making sure that you remember which way x goes and which way y goes. Another way I remember it is that they're always opposite. Here's a y, here's the y-axis this way. And so any line that's parallel to this y-axis is always going to have the opposite letter. So if it's parallel to this one, like this line, or this line over here, it's going to be, instead of y, it's going to be x is equal to. Similarly, if I have a line that's parallel to x, the equation of that line is going to be y equals something. Same here, it's parallel to x, so it's y equals, and then whatever y is equal to, -4. Okay, so those are horizontal and vertical lines. Last concept to take a look at in this section is looking at parallel lines and perpendicular lines. Parallel lines are lines that have the same slope. So when I look at their equation, here I see, hey, the thing in the slope position, remember our y equals mx plus b, the thing in our slope position is the same. Therefore, these two equations, the graphs of those will produce lines that are parallel to each other. Let's just graph them. Y-intercept's -2, so y-intercept's -2 right there-ish, right there. And at rise 2, run 1, rise 2, run 1. Yeah, so that is that line. This line is going to be parallel to that one, but in this case, the y-intercept's at +1. +1, rise 2, run 1, rise 2, run 1, etc. So here I have two parallel lines. Let's check to see if these are parallel. In this case here, this one is in the right format. So I have a slope here and I have a y-intercept here, but I don't have that here. I have to change its form. So let me leave the y where it's at and move the 2x over, so it's minus 2x, and then plus 6. And I'm going to divide both sides by 3, so I'll get negative 2/3 x plus 2 when I divide everything by 3. Now when I look at it, here the slope of this one is 3/2. The slope of this one's different, therefore these ones are not parallel because the slopes have to be identical. However, this one actually introduces the next concept of perpendicular lines. Perpendicular lines are ones that have the negative reciprocal of the slope, whatever that means. Negative reciprocal means if I take this number here, or this fraction, and flip it over, that's the reciprocal part, and change its sign, look down here, that's what I did here, right? Flip this one over, 3/2 turns to 2/3. This one's positive, this one's negative. These two lines here are actually perpendicular lines. Let's take a little bit closer look at it. So perpendicular ones, a line's perpendicular to another if its slope has the opposite of the reciprocal of the other. Opposite means change its sign, so if one's plus, the other one's minus. And reciprocal means the fraction is inverted or flipped over. They're not in the pretty form, the nice form for us, so let's do that. Let's move the 2x to the other side. So I'll just take this first equation and work with it. I'll maybe label it number 1. So with number 1, I've got minus 5y equals minus 2x plus 3. Divide everything by minus 5, so I get a positive 2/5 x minus 3/5. There's the slope, 2/5, 2/5. So on equation number 2, let's change colors. On equation number 2 here, I've got 5x plus 2y equals 8. Okay, let's move the 5x over to the other side. It'd be a minus 5x plus 8. Now let's divide everything by 2. So I get y equals minus 5/2x. 8 divided 2 is 4, plus 4. So now we'll take a look at the slopes. Here's the slope of the first one. Here's the slope of the second one. So are they perpendicular? Is one flipped over and changed its sign? So 2/5 flipped over, sure enough, is 5/2. This one's positive, this one's negative. Therefore, these two lines are perpendicular. And if we wanted to graph them, we certainly could. Okay, so we looked at some other ways of looking at linear functions, other ways of getting graphs of them. So we looked at intercepts as one of the things that could help us graph it. We also looked at this form, making sure the y equals mx plus b could tell me the slope and the y-intercept. Then we also looked at vertical lines and horizontal lines, saw that these ones were x equals something, these ones were y equals something. And then finally we looked at parallel lines and perpendicular lines, like that. Found that these ones, the slopes were the same, these ones, the slopes were the negative reciprocal of each other. Try some questions, holler at your instructor if you have questions.